Continuing our study of parametric equations, we're now going to be looking at parametric equations and vectors. At the end of this lesson, you'll be able to find the position, velocity, and acceleration vectors of a set of parametric equations. All right, first of all, in case you're not familiar with what a vector is a quantity which is described by both a magnitude and direction. And for a parametric equation, the vector components are going to be, they'll look like this, x of t, y of t. So instead of parentheses, we'll usually put these sideways v things to show that this is a vector. Right, so a position vector is going to be exactly what the vector components look like. It's just telling us where a particle is in relationship with x and where the particle is with relationship with y at a certain amount of time. And then velocity, if we know to get from velocity from position, we take the derivative. So this will just be the derivative of the x and then the derivative of the y. Okay, and then the acceleration vector is just the derivative of velocity or the second derivative of position. So it's just going to be the second derivative of x and then the second derivative of y. Okay, and then the speed is actually not a vector. The speed is just how fast this object is traveling, and the way that we're going to get is the square root of the derivative of x with respect to t squared and the derivative of y with respect to t squared. And you'll notice that looks very familiar. Looks a lot like the arc length formula, but we're not taking the integral for the speed. We're just calculating that. And we could also, dx dt is just really x prime, and dy dt is y prime. Okay, so let's jump into the example. Example 1. Consider the parametric equations x of t equals 3t squared minus 2t, and y of t is equal to 6t plus 2. Right. Part A says to sketch the path of the particle, indicating the direction of increasing t. So if we're going to sketch the path of the particle, we'll do this non-calculator. What we'd want to do first of all is just make ourselves an xy table. So I'm just going to start, it doesn't say where we have to start or end, so I'm just going to pick some values like we picked when we did 10, 2. So I'll just do -2, -1, 0, 1, and 2. I think that should give me a picture of what it looks like at least. All right, so if you were to plug t into the x equation and then t into the y equation, we will get, for this we'll get 16 and then -10. We'll get 5, -4. We'll get 0 and 2. We'll get 1 and 8, and we'll get 8 and 14. So when it asks for a graph, I believe I'm going to go by 2's on this. So I'll get 2, 4, 6, 8, 10. 2, 4, 6, 8, 10. And then 2, 4, 6, 8, 10. 2, 4, 6, 8, 10. 2, 4, 6, 8, 10. 2, 4, 6, 8, 10. Okay, that should be good enough, I think. So 16, -10 would be 12, 14, 16, -10. And then we've got 5, -4. And then we've got 0, 2. And then we've got 1, 8 there. And then we've got 8, 14, 8, 13, somewhere up there. So if I start here, it is going in this direction. Remember, we're going to follow from where we started. It's going to go up. And it looks like it's going to be somewhere to the side with where I will. Okay, and it does say to indicate direction, so I will put some arrows noting it's going in that direction. Okay, so that's what the particle is doing. We would like to find the position of the particle at t equals 2. So for finding the position, if you remember, it's just x of 2, y of 2. And notice we already found that. It was at 814, so we can just simply put 814. That is where the function is at. So 814. Right up there, you'll notice that's exactly where we're at. Okay, another way you might see this, it is okay if we put sideways v's. It would be okay if we just put 814 as well. Okay, the next one, it says to find the velocity of the particle at t equals 2. So if we're looking for the velocity, what we are going to do is just take the derivative. So it's going to be x prime of 2, y prime of 2. So I'm going to come over here and do a little side trip. X prime, the derivative of the x will be 6t minus 2. And the derivative of the y will be 6. So when I plug 2 into this equation, I'll get 10. And when I plug, well, I can't even plug anything into there, I'll just get 6. So that is the velocity at time equals 2 with respect to the x and the y. Part D says to find the acceleration of the particle at t equals 2. So what I'm going to do on this one, remember it was x double prime and y double prime. So let me go over here and do my little side trip again. My second derivative, if my first derivative was 6t minus 2, my second derivative is 6. And for y double prime, my first derivative was 6, so my second derivative will be 0. So the acceleration vector will be represented by 6, 0. And then last, it says to find the speed of the particle at t equals 2. We know the speed is equal to dx dt squared plus dy dt squared. And we already found out that dx dt was equal to 6t. Well, actually, we already found it at t equals 2. We found that the derivative at 2 was 10 squared, plus the derivative of the y value at 2 was 6, so we'll have 6 squared. So then from here we'll get the square root of 136, and since I'm not using my calculator right now, that would be my speed. So hopefully now you are comfortable with parametric equations and vectors. We'll be doing example 2 in class tomorrow.